Artificial pollination or assisted pollination is a management practice used in jackfruit cultivation to overcome pollination deficits and ensure the development of high quality uniform fruits. Jackfruit is a monoecious species, meaning it produces separate male and female inflorescences, also called spikes, on the same tree and is naturally pollinated by wind and insects. The jackfruit is a multiple fruit syncarp formed by the fusion of numerous individual fruitlets. Each fruitlet develops from a single female flower within the female spike. For a fruit to achieve a symmetrical, well-filled shape, a high percentage of these individual flowers must be successfully pollinated. Inflorescence identification. Male spikes smaller, slender and usually appear on younger branches. They produce a yellowish green pollen dust when mature. Female spikes larger, thicker and emerge from the main trunk or older primary branches, cauliflory. They have a distinct pebbly surface representing the individual stigmas. Natural constraints. Pollination often fails due to asynchronous receptivity, temporal mismatch between pollen shed and stigma receptivity, or the placement of female spikes in areas unexposed to wind or pollinators, such as deep within the canopy or close to the trunk. The artificial pollination process. Manual intervention involves the physical transfer of pollen from a mature male spike to a receptive female spike. Optimal timing. Hand pollination should be performed early in the morning, typically between 5 am and 10 am, when pollen dehiscence is at its peak and stigmas are most receptive. Selection and collection. Identify a mature male spike which is recognizable by its yellow color or the visible dusting of pollen on its surface. For direct pollination, the spike can be harvested. For indirect methods, a small soft bristled paintbrush or cotton swab can be used to collect the pollen. Application technique. Direct contact. Gently rub or roll the mature male spike over the entire surface of the receptive female spike. Brush method. Use a paintbrush to transfer collected pollen onto the female spike, ensuring even coverage across all fruitlets to prevent lopsided fruit growth. Frequency. Repeated applications every other day for 6 days have been shown to maximize fruit set. Scientific benefits of assisted pollination. Research indicates that artificial pollination significantly outperforms natural pollination in several key metrics. Fruit set and shape. Artificial pollination can achieve a 94 to 100% fruit set compared to much lower rates in natural conditions. It ensures the development of an oblate spheroid shape, whereas natural pollination often results in deformed or irregular fruits. Yield and quality. Studies have shown that assisted pollination can increase the number of developed fruitlets and seeds by over 30%, leading to a higher edible yield and increased fruit weight. Seed development. The number of seeds per kilogram of fruit can increase by approximately 46% with artificial pollination, which is a key indicator of successful fertilization across the multiple flowers of the spike.